All right, so we know we don't know the angle, but we know the cosine is 2/5, and we know that we're in, oh, crazy pen. Oh, what's wrong with my pen? Stop it. Interesting. We know that we're in quadrant 4, so the first thing I really need to do here is draw a picture of this. So drawing my best circle, choose blue. And then draw in my y-axis and my x-axis. Now, usually I prefer to work on the unit circle, but you don't have to. So I have a couple of options on how to draw this picture. I could say if I'm on the unit circle, this is 2/5 is the x value. Or I could pick any circle, sort of, and remember that the cosine is the ratio of the x value to the radius. So if you look at videos on similar problems to this, you'll find there's a couple of takes on this. We could take r to be 1, x is 2/5, or I could take x to be 2 and r to be 5 would be another option just for fun. I'm going to do that to be a little bit different. But usually I like to keep it simple and let the radius just be 1. We're going to branch out here. So let's see. So this right here would be 5, over here 5, over here -5, and over here -5. So there's my radius. And then x equals 2. So let's see if that's 5. Let's see, that'd be about 1, 2, 3, 4. That looks reasonable. So there's 2. And x equals 2, right? So let's think about what it means for x to be 2. X is 2, which is a different color. X is 2 everywhere vertically here. So I have 2 points on the circle where x is 2 up there or down there. And I was told, hey, this one's the quadrant 4 one. Oh, this one's in quadrant 4. All right, so what that tells me then is my angle theta, if it's in standard position, would be this angle right there. So that's theta right there. What do I know about quadrant 2? I know that in quadrant 2, the x values are positive and the y values are negative. So that's going to help me figure this out. So remember, the sine is the y value divided by the radius. So in this picture here, oh, I don't know what the y value is. I got to find the y value, question mark. What could it be? Well, we can figure that out because we have a right triangle we can work with. So let's draw that right triangle. Here's x on the right triangle. Here is y on the right triangle. There's my right angle. There's my radius. X is 2. I don't know y. I know the radius is 5. Pythagorean theorem says if you take the legs 2 and y and you square them and add them up, that has to be the hypotenuse squared. All right, so that's going to be a 4 plus y squared equals 25. Subtract the 4 over, y squared is 21. And I guess I should write what I did to be clear. -4, -4. And then we should take the square root. So y is plus or minus the square root of 21. Which one do we want? Let's see. Positive square root of 21, that would be up there. I want the negative square root of 21. Okay, so the sign in this case must be the opposite of the square root of 21 divided by the radius 5. So whatever this angle is, if the cosine is 2/5, the sine has to be -21/5. Similarly, the tangent is the y value over the x value. So y is negative square root of 21 over 5 divided by x, which is 2 over 5. The over 5s divide out, and I get negative square root of 21 over 2. Secant, what is the secant? The secant is the reciprocal of the cosine. So that would be r over x. And that's something you just got to know or look up. Let's see, r in this case is 5, x is 2/5. clean that up a little bit. If I divide by a fraction, that means multiply by the reciprocal, 5/2. So it must be 25 halves. The secant of whatever that angle is, if the cosine is 2/5, it should be 25 halves. Wait a minute, that doesn't look right. Should be 5/2. Oh, right. I switched my notation between a unit circle and this particular circle. All right, let's write some things down to be clear here. In this picture here, X is 2, Gary. It's not 2/5. Y is the square root of 21, and R is 5. And what happened was I slipped into my default behavior, which is to always work with a unit circle, not a circle of radius 5. So this answer is right. I just wrote it down, the process wrong. So let's fix that. And why did I know I made a mistake? Well, remember the secant is just 1 over the cosine. So the answer should be 5/2 looking up there. Okay, so tangent, double check. The y value is just negative square root of 21. And the x value is simply just 2. I had that as the answer. I just came about it a slightly different way than using this circle. Secant, the radius is 5. And the x value is 2. That's more like it. Again, here's the information I know. Oops, y is negative. Cotangent is the flip of the tangent, so that must be x over y. X is 2. And I meant to have these color-coded opposites, so they're easy to read. Let's go red, blue, red, blue. So x is 2, y is the opposite of the square root of 21. And I don't see the need to clean up the denominator. That's a great answer. And then cosecant is the reciprocal of the sine, so that must be r over x. So there's a couple of ways to memorize what the cosecant represents. And on my picture here, r is 5 and x is, let's see, cosecant, oh, the reciprocal of the sine, that should be r over y. I'm on a roll here. 2 errors, corrected. R over y. So r is 5, y is the negative square root of 21. And so now I have each of those values. Now, since I don't have theta, I really can't check it. The only way I know I'm right is if I apply the Pythagorean theorem to get that missing number y, and that I actually have these definitions correct, which I do now. So those are the values of the other trig values. If the cosine of theta is 2/5 and I'm in quadrant 4, definitely draw a picture.